So what I'd like you to do is somewhere on a paper where you can have it ready to be used regularly, you should sketch or have a printed version of a normal distribution curve like the one that I'm drawing here to the left of our notes, because we're going to be using this throughout the statistics unit to approximate the amount of data that's within a certain range. And so if you look at the actual normal distribution curve, the one that I first introduced last Thursday, you'll see that within one standard deviation, we could add up all of the percentages that we saw within that range, and that would be there was a 15, there was a 19.1, there was another 19.1, and there was a 15. And that was me adding up all of the numbers within that range, right centered around the mean. And that would equal 68.2% of your data. But the empirical rule says let's just call it 68% and be done with it, right? Because we're just approximating anyway. So we're just going to use this number to represent the amount of data that is in this range right here. And so maybe I'll just use red and I'll color that in right now. So I'll just highlight this in red. That's all of this space created in this range by the normal distribution curve. And remember, that space is going to be included in the other ranges as well. All right, so what percent of the population is within 2 standard deviations? Well, if you look at that actual normal distribution curve that you could Google, you could look it up, that's going to be, there's a 4.4 out on the left of that range. There's a 9.2 on the left of that range. Then there's this whole 68.2, which is in the middle of that range. And then another 9.2 and another 4.4, which, if you add all that together, is 95.4%, but we're just going to call that 95% according to the empirical rule. And so in that range, I'll use blue here to be that 95%, and then I'll highlight that blue area. So that is going to be everything all the way out to here, right? And then I'm going to include this area in that 95 as well. All right, so all of this, and including this area as well, that's the 95%. So we've got this 68 in the middle, and that's just between, we could say these hash marks, right, between one standard deviation in either direction. Then we've got this 95% of our data, which includes that 68, but also includes more data than that, out to our 2 above and 2 below the mean. And then if we go within 3 standard deviations, that's going to take that middle 95.4%, and I'm going to add to that a 1.7 that you'll see on an actual normal distribution curve and a 0.5 on either side, which, if we added that all together, would be 99.8, but due to rounding, most people say with the empirical rule, let's just call this 99.7%, just as accurate as we need it to be. And we'll use green here, and I'll just highlight this space in green. Goes out to that range and would include all of this as well. Which means if you have normally distributed data, and I'll call this 99.3 or 99.7%, gets us out to here. If you have normally distributed data, you'll find that 99.7% of your population is within that range. Very few people would be on the outside, but if we really did want to calculate how many people would be on the outside, in an actual value, right, that's just the 0.2 that aren't there, so the actual 0.2. But if we use the empirical rule, then it's 0.3%, because that's the difference between 100% and our empirical rule there. So that 0.3, if I just pick a different color here, maybe I'll use yellow, that 0.3 is represented here on the normal distribution curve. It's not a lot, and does not include this middle area. That's the people that are way to the outside. So let's just use this curve and plug in some real numbers here, looking at examples of how this might be applied in a situation where you actually do have normally distributed data. So an example in our notes here says that at Williamsburg Charter High School, a sample of 600 students' STAR exam scores were normally distributed. And this key term here, normally distributed, is very important because that tells us that we can use the empirical rule and we can use this normal distribution curve the way that we're used to using it in order to evaluate this situation. If the mean score was 860 with a standard deviation of 40 points, and then we've got some questions. So actually, before we do any of those questions, let's just take a look at the information they gave us. They said that the mean was 860, so I want to put that right there in the middle of my normal distribution curve. And the standard deviation is 40. So when I do 860 plus 1 standard deviation, that's just 860 plus 40, which is 900. And I could add another 40. And I could add another 40. And I could also have been subtracting 40. And so this should sort of be your first move when you're dealing with normal distribution. And once you get this information, once you find out what the mean is and the standard deviation is, then you can fill in that normal distribution curve. And now it's just a matter of what data do we want to look at here. So we're asked what percent of the population fell within a range of 820 to 990. So I see 820 there and 900 and, or sorry, not 100, just 900, not 990. And 900 is there. And another way that I could write that would be from -1 standard deviation to 1 standard deviation. Right? This is a range we've discussed. That is this 68%. So due to the empirical rule, I would say that 68%, approximately 68% of our population is within that range. So if you went to the school and you just grabbed a kid at random, you'd have, with 68% certainty, an idea that that kid's score was between 820 and 900 because the data is normally distributed. What percent of the scores were above a 900? And so again, I'm really focusing on this 900 here, but I'm looking at everything from that 900 and above, right? Scores that were above that 900. So I've got to figure out how to get that value. And this is similar to an example that you saw from Khan Academy. Basically what we're going to do here is we're going to take a look at this whole thing and assume that all of our data is 100% of our data. And then what we're going to do is we're going to eliminate the middle. So let's take that chunk of data out. If I do that, and this is the calculation that I'm sort of walking through here, I have 100% of my data, and I just eliminated the middle 68% of our data, right? Because I had the whole bell curve, and then I removed this middle section, which is 68% of our data. And so when I do that, that leaves me with 32%. But remember, that 32% is this data and this data. Now, since our data is normally distributed, half of that 32% is here, and half of that 32% is here. So what I actually want to do is take half of 32, and that gives me 16%. So I know that over here I've got 16% of my data, and I would have also had 16% of my data out here. But it's a matter of removing that middle section according to the empirical rule. So I would say 16% of our students scored above a 900. And then lastly, we have Lionel. And Lionel scored a 940 on his exam. So this is Lionel's score. How many students scored better than Lionel? Well, we could approach this in a similar way to the problem we just solved here, and I'll just choose a different color to highlight. Okay, so I've got like a purplish color here that I'm going to use to eliminate data. Since I want the scores that are above that number, I'm not just going to eliminate that middle section. I don't want to just take that out. I actually want to take all of this out, right? That area. I know I've been a little sloppy here, but this is the section that I want to remove, 95%. So what I'm going to do in this case is I'm going to take the 100% and remove 95%. And that leaves me with 5%. So I know that I have 5% of my data between this area and this area. But how much of that 5% is in each of those places? Well, because it's normally distributed, I just take half of 5% and I get 2.5%. So I've got 2.5% of my data here and 2.5% of my data there. This is helpful, but it says how many students, not what percent of the students. I could say 2.5%. Great, but that doesn't answer the question because I want to know how many kids that is. So if I want to find out how many kids that actually is, I need to take that percent and use it to figure out a number of people that it represents. Since I know that there were 600 students in the school originally, what I'm going to do is just multiply 600 by 0.025. Just going to turn that percent into a decimal and use it, and that gives me 15. So I would be able to say with confidence that 15 students scored better than Lionel because of the information that was given and because I knew that this was normally distributed data.